Okay, so now we made it to the next section where we're now going to start breaking down the statements of the for loop. And I kind of touched on it earlier, planting the seed. So now we're going to go a little bit further to make sure you can see it in the curriculum, as well as keep on practicing to get a good understanding how it works. So we're going to give you a little bit more of a variation to it as well. So if you're new to this channel and you're not a part of the cohort, the curriculum is free. The link is in the description. You can follow along if you like. So without further ado, let's get into the curriculum. All right, that's breaking down the for statement. Having seen several examples, we will now explore the syntax of a for loop in more depth. Recall the first example of a for loop that we looked at was we were iterating over a number 51. So we have this number 51 and we're iterating over it to print out all of the numbers between 0 and 51, which would be 0 to 50. We broke down the flow of the execution. Remember, flow of execution of this loop. Noting that the loop executes once for each of the variables of I. It execute one. We saw that. We practiced it a little bit. And I hope you're practicing it more to really get a good understanding. From 0 to 50. The three components of the loop, variable, loop condition, and the update expression dictate exactly how this loop executes. So far, we have only seen for loops with this exact form. Now, we have this is another iteration. So we have upper bound. We're calling it upper bound. So this is a variable or an object that we created called upper bound. And so we're going to understand more of this anatomy because, like I said, you don't have to hard code a number in here. We're going to use objects more, and we want to get the length or whatever is stored in that object. We want it to loop over everything in that object, and we want to be able to print out what's in that object. However, the three components of a loop statement can take different forms to create more complex looping behavior. This is what I wanted to make sure you understand, why it's important to understand what it does, not just to memorize the syntax. The general form of a for loop is initial expression, the loop condition, and the update expression. Let's look at each of these three components that affect how the loop iterates. Initial expression. The initial expression means this is something we want you to remember. It's executed once. Before any iteration of the loop, it can be any expression, even the empty expression, which contains no code. However, it is almost always declares and initializes a variable known as the loop variable. Remember, this is just a loop right here. This I is a variable. It is a variable. It is a variable. I want you to make sure you understand it so you can give it whatever name you want to give it. It's just got to make sense. The loop variable can be initialized to any value. We can initialize this to 3. We don't have to initialize it at 0. It can be whatever you want to initialize it to. You can call it whatever you want to call it. Like I said, you can call it a count, and you may want to start the count at 1 instead of 0. It's up to you. You just got to understand what result you're looking for. This loop prints each of the letters C, O, D, and E on a separate line. How did we do that? Because we wanted to start at 6, at index 6, which will start at the letter code, C of the word code. And it's only just going to iterate over it that 4 times. That's all it's going to print out. So this is the initial. Remember, the beginning. It's the beginning of your loop. To avoid confusion and bugs, you should give your loop variable a unique name, one that you have not used elsewhere in your program. In cases where the loop variable is serving as a counter for iteration of a loop, it is conventional to use I for the variable name. In the case of nested for loops, loops inside of loops, because we can do that, the variable j, k, etc. are often used. The loop variable is typically used by the loop body, but this is not required. The following example is a valid for loop that prints launch code 42 times. Now, pay attention to what we're saying here. So remember, when I did the example, every time it loops, it's going to run this console.log on each iteration. Remember, I had the launch code and then the letter, launch code, then the letter. This is what that does right there. So if you just go ahead and play around with this and you run this loop, it's going to run launch code 42 times. This is why it's important to understand what it does instead of just memorizing the syntax. Because you might have thought you needed to only initialize a variable name program language or name and put launch code in it, but you didn't have to do that. There's always more than one way to do something. Loop condition. The loop condition is executed before each loop iteration. It is always a Boolean. Remember, always a Boolean expression. And remember what a Boolean expression is. Evaluating to true or false. If the condition is true, the loop body execute. That means it keeps going. It won't stop until it hits false, until the condition is false. The loop execution stops and the program continues with the next line of code below the loop. So this is what we mean right here. Now this is a -1. Now this loop does not iterate at all because its condition is false to begin with, because there is no -1 inside of when we do an index. It starts at 0. So this is why you need to understand what an infinite loop is, how that works, because that's what we're about to go over now. It is critical that the loop condition eventually becomes false. A loop for which the condition is never false is known as an infinite loop because it never stops iterating. This is why it's important that you understand what the result will be before you write the code. Because if you don't understand, you may not know you're writing an infinite loop. A program that contains an infinite loop will only stop after running out of memory or being manually stopped, for example using Control-C in the terminal. So this is an infinite loop because its condition will always be true, because what? 0 is always going to be greater than -1. It's going to always be. So it's never going to evaluate to false. So this is just going to keep running. Now I won't show you because it's going to run out of memory and it'll crash. So, you know, that's what infinite loops do. It will crash your system. You will accidentally write an infinite loop at some point. Doing so is a rite of passage. For new programmers, when this happens, don't panic. Stop your program and figure out why your loop condition never becomes false. Understand the rule and the principle. Now we're to the update expression. The final component in a for loop definition is the update expression, which executes after every iteration of the loop. While the expression may be anything While this expression may be anything, it most often updates the value of the loop variable. It's going to update the value of the loop variable. But what we're saying here, it could be anything inside of the updater, whatever you're updating, whatever is in your object. In all of the examples we have seen so far, the update expression has I++, incrementing the loop variable by 1. However, it can update the loop variable in other ways. Here's the syntax right here. I++ means just right here, this example, I assign a I plus 1. That's what I++ is the shorthand for that. But we don't want to do it by 1. We want to do it by 2. So if you're going to do it that way, if you want to increment by 2, you have to write it out this way. You can't just do I++2. It has to be I equal I plus 2, which this is an assignment operator. So I'm assigning I 2 times to the updater. That's what that means. So play around with this so you can get an understanding. A bad choice of update expressions can also cause an infinite loop. Here we go. If you do a decrement, which is the dash dash, this is never going to be true because I will always be less than 21. I mean less than 51. That is an infinite loop. Now, how does each of these components affect the behavior of a for loop? So go ahead and open up your variable file in JS in VS Code, and then go ahead and play around with the code. Modify, do what we're asking you to do so you can get an understanding. I've given you enough of the tools to be able to understand how this works. So check your understanding. And now that after you check your understanding, we have now come to the end of this particular section. And again, keep practicing. The more you do, the more you improve. See you in the next section.